So we're going to go ahead and get started on our next section with limits in our first unit. But before we get there, I do want to take a second and talk about the homework. So we first completed the very first section, 1.1, and if you notice on page 21 in your notes, there is some homework. Now, I will be putting odd solutions on my teacher page, so you can check those out and see how you do. The homework should not be very extensive. It's normally never more than 2 pages front and back. So I know we have these video assignments to do on some nights, but you will also have homework and practice problems to do. So my suggestion is when you get done with a video assignment, maybe try some homework problems just to see or check your understanding, and then we can always bring some questions into class. We will definitely be having homework days in class, so we're not always going to have an activity where we're in groups. There are going to be some days where I'm just going to say today's a homework day and you're going to work on these problems and ask questions. So not all of the homework is going to be done outside of class. So let's go ahead and get started on our next section on page 25, continuing to talk about limits, but this time we're going to take an algebraic approach, meaning by hand. So we're not necessarily looking at limits on a table or a graph anymore. We're going to try to figure out what a limit is by just looking at an equation. Okay, we're going to figure out by hand. So to kind of ease us into this, we have this absolute value graph to the right, and the function is given to us at the top. We're going to evaluate a function value and then compare that to a limit value. So in our first instance, notice how x is approaching 0. So let's first find that function value. If you were to plug in 0 into your equation, now you could also look at the graph, that's another helpful hint, it looks like we would get out -2. Let's see, if we were to plug in 2 into the graph, we would get -4. And if we were to plug in 10, notice how that's off of our graph, so definitely using the equation in this case. -2 times 10 is -20, plus 4 is -16, absolute value changes that to +16, times 1/2 is 8, and -4 would be 4. So we're going to see how these function values compare to the limit values. So let's actually evaluate these limits. If we were to approach 0 from the left and the right, notice how we would be approaching that height of -2. If we were to just approach 2 from the right, we're getting closer to a height of -2. And let's see, if we were to check out x approaches 10, now we don't really have that capability on the graph itself, but perhaps you're starting to see a pattern after we completed those first 2. So we'll probably make an educated guess here and say that would be 4 as well. So this pattern is kind of leading us into an easy way for us to figure out limits by hand. So what's this connection that we're actually looking for? It seems that if we were to approach a number from the left and the right, that would actually equal the function value at that same point. Now notice how this has a stipulation. Okay, the function has to be defined and continuous at this x value that you are approaching. So no holes, no jumps, no asymptotes, and we have a closed circle at that spot. So if we're trying to evaluate a limit by hand, we can easily just use a function value instead. The moral of the story for this is we're always going to try substitution first. Okay, a function value, we're going to plug in a number and see what we get out. So that's what the bottom of this page is going to help us practice. Okay, notice how we're going to find the limit of this equation. We don't know the graph of the equation, we don't know the table of the equation, but we can figure this out by hand. Okay, so let's go ahead and we're going to simply substitute in 3. 3 squared is 9. Half of that, we'll have 9/2. Plug in 3, we'll have -6, and then a +3 on the end. So 4.5 minus 6 plus 3, that would lead us to 1.5. So as we approach 3 from the left and the right of this parabola, our graph is approaching a height of 1.5. Okay, kind of simple. We're plugging and chugging. If we try the next one, we're going to substitute in 3. So we'd have 15 plus 2 over 6 minus 3, which will give us 17 over 3. All right, so on this particular graph, if we had a picture of it, if we were to approach 3 from the left and the right, we would be getting a height of 17/3. Now, taking a look at C, this one might be a little bit different because we have that left-handed side approaching, but the left-hand side, when we are evaluating limits by hand, we're just simply focusing on the number itself. We don't necessarily care if we're coming from the left and the right. We just want to test to see if we were to plug in that number, would we get out a value that made sense? So we're simply going to plug in 2, where we get the square root of 4, which is 2, and then minus 1 would be 1. And plugging in 2 down below, we would get 1/3. Moving on to some trig, if we substitute in pi over 2 times 2, we would just be left with pi. And this should be a point that we are familiar with or we know exactly. Sine of pi is 0. So another trig one, we're going to plug in 2 pi over 3. The cosine value at that point, you may need to use the unit circle to help you with that. It would be negative 1 over 2. And we're going to plug in 2 pi over 3 in for theta down below. So instead of dividing by a fraction, you could bring it up and multiply by the reciprocal. You would get negative 3 over 4 pi. A little weird because I know that pi is in the denominator, but nonetheless, this is still a value and it's representing the height you are approaching as you get closer to the left and the right of that theta value. For our last one, we're going to plug in 9. 11 minus 9 is 2, so we're going to try to figure out log base 8 of 2. Remember, logs represent powers, so we need to think about what power do we have to raise 8 to get an answer of 2, and that would be the cubed root of 8, which would be a power of 1/3. If that's a little confusing, don't be too concerned about that because we will talk about roots and powers a little bit later on in this course.